London and Kiev sit on almost exactly the same latitude.
Yet London's average winter temperature hovers around plus 5 degrees Celsius, while Kiev endures -3. An 8-degree difference on the very same geographic line. The reason is not magic. It is a colossal river hidden inside the ocean, one that pumps 100 million cubic meters of warm tropical water toward Europe every single second. That is 100 times the combined flow of every river on Earth. This river is called the Gulf Stream, and for millennia it has functioned as a giant central heating system for half a continent.
But there is a serious problem. Over the last 30 years, this current has slowed by 15%, the most dramatic weakening in 1,000 years. If the trend continues, Europe's climate will change in ways that are almost impossible to overstate. In the next few minutes, you will understand exactly why the Gulf Stream could stop and what happens to the world when that natural heater finally switches off. How the Gulf Stream actually works: a giant ocean escalator. The Gulf Stream is not a standalone current. It is one arm of a far larger global system that scientists call thermohaline circulation, a term that simply means circulation driven by temperature and salt.
Think of it like a kettle on a stove. Differences in heat and density keep the water in constant motion. Warm surface water from the Caribbean Sea moves northward along the American coastline, carrying tropical heat toward Europe at a speed of roughly 2 meters per second. By the time this water reaches the North Atlantic near Greenland, something critical happens. It cools down. Evaporation makes it saltier. Cold, salty water is denser, heavier than warm, fresh water, so it sinks to the ocean floor and flows back toward the equator as a deep, cold undercurrent. Picture the escalators in a shopping center. One carries you up, the other brings you back down. Together they form one continuous, unbroken loop. Thanks to this loop, Europe receives an amount of heat equivalent to the output of 1 million nuclear power plants every single day, free of charge, delivered by the ocean itself. What Europe would look like without the Gulf Stream. To appreciate what the Gulf Stream does, it helps to imagine what Europe would look like without it. Scientists have a ready comparison: Labrador, on the eastern coast of Canada. Labrador sits at roughly the same latitude as Britain, but without any equivalent warm current, it endures winters of -15 degrees Celsius. That is what the British Isles would face, not the mild, rainy winters Londoners complain about, but deep, sustained Arctic cold. The vineyards of France and southern England would give way to frozen tundra. Scandinavia, already far north, will become largely uninhabitable for the better part of the year. The agricultural heartlands of northern Europe would lose the growing seasons they depend on. This is not speculation. It is simple physics. The Gulf Stream has been operating steadily for the last 8,000 years, acting as an invisible but indispensable pillar of European civilization. And now, for the first time in recorded human history, that pillar is showing cracks. Why the current is slowing down: the Greenland problem. The crisis begins in Greenland. The island's ice sheet is melting at record speed, shedding approximately 280 billion tons of ice every single year. All of that ice becomes freshwater, cold, light, and far less salty than the surrounding ocean. As it pours into the North Atlantic, it spreads across the surface like a film of oil on water, forming a vast freshwater lens that sits on top of the denser salt water below. This is precisely where the ocean conveyor breaks down. Recall that the entire deep water return current depends on cold, salty surface water being heavy enough to sink to the ocean floor. When the surface is diluted with fresh water, that sinking mechanism weakens. The water simply cannot descend far enough to drive the return flow. It is like trying to drain a bathtub while someone continuously pours fresh water in from above. The drain loses its pull. Research from the Potsdam Institute for Climate Impact Research confirms that the current is already 15% weaker than it was in the 1990s. Analysis of marine sediment cores, combined with measurements of water temperature, salinity, and ocean surface height, all point to the same conclusion. The system is losing strength. And the most alarming part is not the slowdown itself. It is the possibility that beyond a certain tipping point, the process becomes self-reinforcing and irreversible. We have seen this before, the Younger Dryas warning. As unsettling as these findings are, Earth has lived through something very similar before, and the geological record has preserved every detail. Roughly 11,000 years ago, as the last ice age was drawing to a close, enormous ice sheets covering North America began to melt. Vast quantities of freshwater flooded into the North Atlantic, and the Gulf Stream abruptly shut down. What followed is known as the Younger Dryas, a period that geologists can read as clearly as tree rings. Within just 10 years, not centuries, not decades, but 10 years, average temperatures across Europe plunged by 15 degrees Celsius. Glaciers that had been retreating reversed course and surged forward again. This brutal cold snap lasted for roughly 1,200 years. We know all of this because of ice cores drilled from the Greenland ice sheet. Those cores preserve annual layers of ice like the pages of climate diary, each layer recording temperature, atmospheric composition, and even microscopic pollen grains from the plants alive at the time. The data shows no gradual cooling. It shows a cliff edge, a sudden, catastrophic collapse of warmth, as if someone had flipped a switch. Corroborating evidence has been found in the peat bogs of Ireland and in Atlantic seafloor sediments. The Younger Dryas is not a theoretical scenario. It is a historical fact. It happened. It was catastrophic. And the conditions now developing in the North Atlantic bear a troubling resemblance to those that triggered it. What a weakened Gulf Stream would mean for the world today. If the Gulf Stream were to slow substantially or collapse entirely, the consequences would be deeply paradoxical. The rest of the planet would continue warming due to climate change, but Europe and parts of North America would grow dramatically colder. Computer models project a fall in average annual temperatures across Britain of 5 to 8 degrees Celsius and across Scandinavia of 10 to 15 degrees. Winters would resemble those of Siberia. Summers would be short and cool. Agriculture across northern Europe would be devastated. Wheat would fail to ripen, crop yields would collapse, and fishing industries would suffer as commercially important fish species follow the retreating warm water south. The impacts would not stop at European borders. A weakened Gulf Stream shifts the tropical rain belt southward, triggering severe droughts across sub-Saharan Africa and South Asia. The eastern seaboard of North America would see sea levels rise by an additional 30 centimeters because the current's pull actually holds water away from the coast, and without it, that water surges back. Perhaps most sobering of all, research from Yale University suggests these changes could unfold within 20 to 50 years, not over centuries as scientists once assumed. The generation being born today may witness the transformation of European climate within their own lifetimes. Can we do anything, or is it already too late? The difficult truth is that we cannot simply switch the Gulf Stream back on. Ocean circulation operates on planetary scales and responds to global forces that human technology cannot directly manipulate. But that does not mean we are powerless. The root cause is clear. Greenland's ice is melting because the planet is warming, and the planet is warming because of greenhouse gas emissions. Every fraction of a degree of warming avoided buys the Gulf Stream more time and stability. Scientists estimate that if global average temperature rise is held below 2 degrees Celsius, the central target of the Paris Agreement, the risk of a full Gulf Stream collapse this century remains manageable. But if warming exceeds 2.5 degrees, the probability of collapse rises to around 50% within this century. That is, in effect, a coin flip with the climate of an entire continent. Some researchers have proposed more radical interventions, injecting reflective particles into the stratosphere to cool the Arctic, or artificially increasing the salinity of critical ocean zones to restore the sinking mechanism. These are real proposals, but they come with profound and unpredictable risks. No one fully understands what large-scale interference in ocean systems might trigger elsewhere. The most realistic and responsible path forward is a combination of two things: aggressive emissions reduction to slow the melting at its source, and serious preparation for the changes already locked in. European governments are already developing contingency plans covering energy infrastructure, food systems, and coastal defenses. The question is no longer whether the climate will change. It is whether we will act quickly enough to keep that change within survivable limits. The Gulf Stream is not a footnote in a geography textbook. It is a life support system, one that has sustained hundreds of millions of people, shaped civilizations, and made entire regions of the planet livable. For 8,000 years it ran like clockwork, so reliably that we simply forgot it was there. But the geological record is unambiguous. This system can fail. It has failed before, and when it does, the change is not gradual. It is sudden. Over the last 30 years, we have already seen the first measurable signs of weakening. The science is telling us clearly where this trajectory leads. The decisions that determine how far down that road we travel are being made right now by governments, by industries, and by each of us individually. Knowledge is the first step. If you found this video worthwhile, please share it. These are conversations that need to reach as many people as possible. Subscribe to the channel so you never miss new content that explores the science and hidden forces shaping our world.